Hello, my name is Mark Smith. I'm a Senior Marketing Manager at Microchip Technology, and today we're going to talk about inductive position sensors. So what is an inductive position sensor? Well, here's an example. This is a linear sensor, and the sensor itself is actually traces on a PCB board. There's traces right here, and there's our Microchip IC located right there. Now the sensor will sense a piece of metal. In this case, I'm using a penny, but that piece of metal can go in front or behind, and we can then accurately measure the position of that piece of metal. Another example would be this rotary sensor, and I'll pick this rotary sensor right here, and this is measuring an angle. And there's a piece of metal underneath this knob that as I turn, it is then determining the angle of that piece of metal. And there's our IC, and then the sensor once again is traces on a printed circuit board. Now the advantages of this technology is very accurate, it's immune to stray magnetic fields, and does not require a magnet. What other applications are available that you would want to use this technology? Well, for automotive applications, there's a whole bunch. In fact, in today's cars, there's maybe 50 magnetic position sensors in a car, and these are some of them. These have a very good for inductive sensing. One example could be your accelerator pedal, or a gear shift inside your car, or your steering angle or torque sensor, or even the main e-motor resolver replacement solution. And other technologies that use magnetic properties are your traditional Hall effect TMR sensor or MR sensor, and inductive technology is a replacement for them. The advantages, as I said before, are they're more accurate. Inductive technology is more accurate. It doesn't require a magnet and is immune to stray magnetic fields. Here I'm in front of a demo here that's showing two of these particular applications from an automotive market. And one would be here's a pedal showing right here, and there's two sensors underneath this. And then this generates signals to a motor control board up here, or your ECU, and then that controls this actuator, this air valve actuator right here. And at the end of that shaft is another piece of metal, and there's an inductive sensor right there. Now the reason why this has two is it's a safety critical application, and for safety critical applications inside cars, they need that redundancy, and so they'll use often two ICs to do the same thing. Now there's two products that we have in production today that can help you build your next inductive position sensor, and that is the LX3301A and the LX3302A. And the difference that you would want to use one or the other is one is which temperature range you want to run to. If you're going to use the 3302A, then you can get up to 150 degrees C, or this would be for your motor applications or under the hood type applications. If you're looking at a lower temperature range like grade 1 or 125 degrees C, you would use the LX3301A. And then the other way you would choose it is what kind of output interface that you want to provide that signal out. Do you want an analog signal that represents position? Do you want PWM signal? Both of the ICs can do that, but we also, the 3302A has the ability to do some digital protocols like CENT and PSI-5, and they can also do raw sine and cosine signals, very similar to your traditional magnetic resolver solution. So for your next inductive position sensing applications, we encourage you to use this technology and see the advantages of more accuracy, better immunity to stray magnetic fields, and you don't need to use a magnet. Thank you very much.